And it's not gonna. Alright, it's recording. It's recording now. Whoops. I didn't mean to choose D. Ah, okay. We'll figure that out in a second. I'll change it. Alright, can everybody see this okay? Now, you guys need two things. You need to have your Chromebooks open to this question. And you need to have your notebook out in case there are any notes that we want to take to help you with this question. Now, looking at your graphs, do your graphs look just like this, or are they a little bit different?
I have this.
Okay, just like that? Okay, some questions are gonna look just like it, and some questions will be like, hey, mine doesn't look like yours. So we're gonna work out mine because this is like the example, and then if yours is different, you can apply what we did to how you're going to solve yours, because the method will be exactly the same. Okay, so yesterday we talked about identifying the domain and range of a function. They're giving us two functions here. One question I got yesterday in class was when they saw this, they said, but this one isn't a line. Yes, sometimes functions are curves. Sometimes it looks like a smiley face. Like they can be lots of shapes and sizes, but what's important is identifying all of our x values for the domain and all of our y values for the range. I don't know why my y sometimes look like x's. My domain values are my x values. My range values are my y values. Okay? So let's look. I think this is for part A, right? It says identify the domain of the function. So what values are we looking for? Our x values, right? Domain is our x values, also known as our input values of the function. So I always read all the directions because sometimes that gives you little hints on how to do it. Select the correct choice below, and if necessary, fill in the answer box or boxes within your choice. So obviously, if we're going to choose E, then we don't have anything to fill in. But if we make any of these other choices, not only are we going to select them, but we also have to fill in the blank on it. So let's take a look at our function. Before we even look at any of these, let's take a look at our function and get to know it a little bit better. Again, we are focusing on the x values, all of the x values that are contained in this little curvy curve here, right? So you can do it two ways. One way you can do it is you can actually identify the coordinate pairs of each of those endpoints. So these are pretty easy because they have those perfect intersections on our graph. And this point would be what? What would be the coordinate pair for this point?
3 to 4.
For this point right here?
4. Oh wait, 4 and 1.
Let's try that again.
1, 4.
1, 4 is correct. 1 on the x, up 4 on the y. Now for this point, 3, 0 is correct. So what we're trying to kind of measure is how far on my x-axis it's going from this point to this point. Even though it's sliding down, we don't really care about the going down or up with our domain. We care about how much space it's covering on our x-axis. So we're going from the x-axis here at point 1, or at interval 1, and then going to all the way. This one's easy because it's right on the x-axis, right? So notice how I'm measuring from kind of like here all the way to here, and I'm actually gonna fill in a little circle there because our red circle was filled in. So I'm measuring my domain from here to here. I don't have intervals identified, but we can tell by what intervals we are seeing that this would be 1 and 3. So the second way to identify this is to notice that the distance of the domain is from 1 to 3, and hey, that is both of our x values on our points, 1 and 3. Do you guys see that?
Yeah.
Okay, so going from 1 to 3 on our x would be our domain. tell me if we should include the values 1 and 3 or not include them. Include why? Because what?
They're connected and the 4 and 0 are not.
4 and the 0 now. The 4 and the 0 represent the y values of the coordinates, so that has nothing to do with our domain. But how do we know that we need to be inclusive, aka use an or equal sign to? How do we know? What about this graph shows us that we have to include the numbers 1 and 3 as part of the domain? Because sometimes we write 1 and 3, but we don't actually include them as our answer. For example, if I were to say x has to be in between 1 and 3, right? This would be the way to write it without including the 1 and 3. This would be the way to write it including the 1 and 3. What about our graph helps us determine which inequality is correct? Yes.
The dots.
And what about those dots?
If they're open or closed.
Yeah, if they're open or closed. These dots, I know I kind of wrote over them, but I wrote over them the exact same way that they are written. They are closed dots, which is why when I kind of redotted them, I kept them closed. Because they are closed dots, we want to go with the inequality that is inclusive. Inclusive means 1 and 3 are not only our endpoints, but they are also included as x values in the domain. Does that make sense? Okay. All right, so we're not using this one. We're going to use this one. Let's find the answer choice that matches up with that. A, no, B, no, here. That's gonna be our answer, right? So we're gonna choose C. Oh, I should just like click it because I accidentally clicked D by accident. All right, and then we're gonna fill in our endpoint values. 1 and 3.
I'm confused, Mom. Wait.
Do you have a different graph?
No, that's the same except it's on A.
This is A.
No, like the answer. It wasn't C.
Oh, are they mixed around? Okay, yeah, be careful of that sometimes
Yeah.
just because they're trying to kind of prevent cheating. Because if like, and the A is like, what'd you get for that? And you say, oh, I got C. And she's like, has that on A, then it's gonna prevent the cheaters. Not that you guys would ever do that. Okay, so wherever that answer is, that's what you want to select. Are we good for that part?
Yeah.
Good. Okay, so I'm gonna just let that, oh, I have to type it in.
There's a part B.
I know. I'm gonna
There's
go.
4 parts.
I know, isn't that funny how I'm like, oh, I only assigned 6 questions.
But it wasn't just Saxon. It was all like all 30 questions.
Oh,
Or
girl, I do
3
Saxon
parts.
every night with my daughters. I do 60 problems a night with my daughters. It is.
My mom counted it, and then we did 75 problems.
Oh, I know, because then like 5 problems have A, B, and C, and then you have to like draw a graph for one of the
Yeah.
problems. It is intense. It takes us a long time to get through homework at night.
Yeah, my sister took like literally like more than like 3 hours.
Yeah, sometimes it really takes that. It's sad. It's sad because it's a
And I
lot of
only
work.
take 1 hour.
Okay, so the next part is identify the range of the function. So we're going to do the same exact thing on that graph, except we're not looking at our x values anymore. We're looking at our y values. Very good. So let me see if I can bring this down a little bit. That
No, it just makes it bigger.
didn't help at all. Why can't
You
I?
can make them bigger. You can make the graphs bigger.
Okay, maybe I pop this out. Okay.
Oh, that's cool.
Okay, that didn't really help though.
You can hit like the plus button, the plus magnifying button.
Yeah, maybe I'll do that. It says okay. You're like, okay. Okay, and then I can do this?
Yeah.
Okay, I see it. I see that. There we go. That kind of eliminates that part. Okay, I like it. Okay, it's still not exactly what I wanted it to do. But let's go ahead and look at our graph and determine our range. We don't really need the answer choices while we're doing this. So let's determine it on our own and then match it up with an answer choice, okay? If we're looking for the range, what are we looking for? The y values. Okay, so we're looking for how far this function travels upward and downward. Now again, let's name our coordinate points. We have 1, 4, and we have 3, 0. What we're looking for is the y on the y-axis. How far does it hit up, and how far does it hit down? And then of course it's going to be all of the values in between that, but the way we're going to name it is using kind of our limits, our endpoints, okay? So notice how where it hits up here happens to be our y-coordinate, 4. Where it hits down here happens to be our y-coordinate on the low point, 0. So we have between 0 and 4. When we're writing our compound inequality, we always, yeah.
Why don't you just be like 4? Yes.
No, because we have to include all of the possible values for y. So we're not just looking for the highest value for y, we're looking for the highest and the lowest. When we write that as our compound inequality, we'll say y is in between 0 and 4. Make sure that you're writing from least to greatest.
Okay.
And why did I use my inclusive symbols?
Since the dots are not open.
Since they're what?
The dots are not open in the other points.
You said they're not open?
They have to be close to.
Yeah, they have to be close to.
Are the dots closed or open?
They're close.
Yeah. You said because the dots are not open.
Yeah.
Oh yeah!
Yeah,
I was confused by like using the not. Okay, it's because they're not open, they are closed. You're totally right. My brain took like 5 seconds to like actually process that is correct. You are totally right. Okay, so yes, so we're gonna use this, we're gonna use inclusive, and then let's scroll down a little bit and choose which one that would be. So this would be y. This is our set builder notation, so we're going to choose, for me, it's E. That would be 0 and 4. You good?
Do all these have like 4 parts?
That's not going to do, I don't know.
No, 1 and 2 have 4 parts.
Oh, okay, okay, here we go. Okay, so now we're looking for the other graph, and we're going to identify the domain of this graph now. You know what, I'm just gonna go ahead and pop it out. There we go. We're gonna identify the domain of this graph. Talking about domain, so what values am I talking about? X values, good. Now, are we going to have an X is in between two numbers type of situation? No, why not?
Because it's not 2 dots. There's no points.
Yeah, there's only one endpoint, so we will have a limit there, but then there's not going to be a limit on the other side. So it still will look like an inequality, but it's not going to be in between two numbers and constrained like that. It will have a constraint here. Let's look at our point here. It's 0, 1, right? So our x value is 0. So that means x, can it be 0? Can x be 0?
Yeah.
Yes, why?
It's not going to be. Well,
Because it can be 0, right? Because
yeah.
it's a closed circle,
Yes.
right? But what does it also have to be? Not just 0, but what?
A positive number?
Yeah, we would call that anything greater than 0 as well. So it can be 0, which is equal to, or greater than 0, because it's all of the positive x values. It's going to keep going on forever. So we would write that x has to be greater than or equal to 0. Equal to because the dot's filled in.
Why can't we just do 1, 2?
1, 2.
No. I mean, like, why can't we use 1?
Because you
we're
mean
just doing the domain.
correct. The 1 will be on the range. Okay, so we have x is greater than or equal to 0.
Alright, now we got part 4.
Okay.
And this one. This one.
Yeah.
Do you want to know what I got last year for my stacks of math book? I
Um,
got a teacher's edition.
oh, you did? That's
Yeah.
interesting.
They gave me a teacher's edition, so I had every answer.
Okay, so now they're asking for the range of the function. So I'm going to go back up to here, pop it out.
Oh.
Now we're looking for the range, which is our what values?
X, Y.
Our y values. So we're looking for the y values, and our y value starts at what?
0 or 1.
It starts at 1, because again, our coordinate is 0, 1, 0 represents the x, 1 represents the y. So for this, what you were trying to say before, but when you were kind of skipping ahead to the range, we're going to say x has to be what?
Equals to, oh, wait, less than? Greater than.
Greater than or,
Equal to.
yep, greater than or equal to 1. Because it starts at 1 and includes 1, but our y's are going to continue being included as this line increases. It looks like it's getting far from the y-axis, right? But it doesn't matter how far it gets from the y-axis, it's still hitting all of those y values as it's continuing upward. No matter how far it gets, it's still going up and up and up on the y. So it's simply the x is greater than or equal to. Huh? X is, oh, I'm sorry. Ah, I wrote x, I meant to write y. Why didn't anybody stop me? We're doing the range. I should have.
forgot to put Y instead of X. Go myself.
Oh my god, that was so easy. Way to get it, Valerie.
And she caught it. Okay. So y is greater than or equal to.
That was ridiculous.
I know, that was a little overly generous.
Now
This is not one.
Everything okay there? Oh. All right. Oh, now it wants me to go to the next thing.
Kelly.
Oh, good. Part 1 of 5. All right, I'm going to move a little bit faster now. But we're getting it. Why in the world is it all the way over there? Let's see. It says identify the domain of the function. So this little a here is referencing that we are looking at graph A. These are totally different graphs. Let's see. Okay. So here's our graph that we're looking for. And or a little table. Identify the domain of the function. Now, our domain, it doesn't tell you here, but there's kind of an invisible x and y table here. So this is kind of easy to identify the domain, right? What's our domain?
Oh, 1, 3, 5. 1, 2, 3, 4.
Good. Is 1.5 included in this?
No.
No. In this table, it is specifically listing 4 numbers and only 4 numbers. It's putting a 1 into the machine and out comes a 3. It's putting a 2 into the machine and out comes a 3. So all of our inputs are simply 1, 2, 3, and 4. This isn't written as an inequality, this is written as a set of numbers. So for this, you just choose the box. I don't know if it's A for you, but for me it's A, and it says type your answers as integers or simplify fractions, which is not necessary in this case. Use a comma to separate answers as needed. So you just type 1, 2, 3, and 4.
Good job.
Thank you.
We're doing for commas.
Yeah, you put commas in between your answers so they know they're separate numbers. Now it says identify the range of the function. You guys, what is the range
Oh
of
my
this
gosh,
function?
this is so
The
hard.
range is 3 and only 3.
Oh my
Very
gosh.
good.
You just said you said
Which one is it the box again?
Yeah, this one. Well done. I love the encouragement. And do you guys notice when you do get an answer wrong and you get the pop-up, it doesn't just tell you that you're wrong, it gives you a hint as to where you went wrong and how to solve it. Do you guys read that to make
No.
you guys should read it because
Well, I
it,
read the first sentence and then I'll
yeah, as long as you read that and helps you give you a hint.
Well,
on
I've
how to
never
solve it.
heard
I do the
something
way
wrong
it
on
says
the
it to
homework,
do, so
so-
like I don't read it, because the point is I redo the way it says it.
I look at the example sometimes and then if I still get it wrong. Like I'll do the example and write it down and
Yeah.
replace the numbers with more numbers.
Yeah. Okay, so now we're on to the B graph, and it says identify the domain. So let's go up here and pull this, make this big. Okay, let me pop it out. Let's identify the domain. What's the domain? Our x values. So that means all of the values that can be included as our x values. What do you notice about what this line is doing?
It's gonna
Yeah, it's going straight in both directions. Are there any endpoints? There are no limits to the domain, right? So how do we describe a domain that has no limits?
Zero.
Not zero. Zero is one
Undefined.
specific value.
Unreal number. Undefined.
Not an unreal number.
Unreal number.
All real numbers, right? X could literally be like, name a number, and X could be it. Even if this graph goes on and on and on to like positive a trillion, then a trillion could be an X value. It could go to negative quadrillion, and it would be an X value. And it could go to like a quadrillion 0.6, and that would be an X value. So we couldn't even sit here and name all the X values because the X values are real numbers. The domain is real. X is a real number, any real number.
Are you right?
Okay, so now we're looking at the range.
It's the range of real numbers too.
Well, let me ask you this. I'll pop it out again. What value or values is y allowed to be according to this linear function?
All of them.
So you're saying that, let me ask you a question. I'm just gonna plot some points, okay? Let me plot a point right here on the y-axis. What's that coordinate pair? 0, 3 is correct. What's this one?
0. 2, 3.
2, 3. What's this one?
4, 3.
If I keep going and going and going and asking you for more coordinate pairs, what are all your outputs? Your y values would be 3. What if I go in the negative direction and I say, what's this point?
3.
Negative 1, 3. We see that our domain is just all these numbers that just never ever end. We can't limit them. But the y values are all 3. So what's our range? 3. That's it. It's gonna be 3.
It's gonna be fun.
Wait, just 5 part?
I think this is the last part. So it would just be
No, this
this.
No, there's another part. It
What?
says C, functions, length.
Okay.
and domain.
I know these are tricky because you have to fill in so many blanks that you actually like kind of lose track of what the sentence is actually saying. So what we do when we fill in these blanks is we look at the choices that it gives us and decide which choice makes the sentence make sense. So here, let me see if I can.
Functions.
the functions blank the same domain.
Do not.
So either both functions have the same domain or they do not have the same domain. Let's take a look at our graphs again.
Wait.
Our domain over here was 1, 2, 3, and 4. Our domain over here was all real numbers, right?
So they don't.
So they do not. The functions do not have the same
range.
domain. The functions have the same range because we see the range over here is 3 and the range over here is also 3. It's 3 no matter how far it goes along the x-axis. The y will always be 3. Oh my gosh, okay, the functions have the same range. Blank a continuous domain. Neither function has a continuous domain. Both functions have a continuous domain. Okay, so let's look at continuous or discrete. Is the domain for this guy continuous or discrete?
Discrete.
Discrete, very good. Discrete, and then continue. Remember, if you can match up the letters of discrete to each individual interval without connecting them, then it's discrete. Is the domain continuous or discrete for this?
It's going to be
Continuous.
It's continuous, continues in both directions. So we've got not continuous and then continuous, so let's see how we can write that in as our answer choice. So only the function from part B has continuous. Blank has only the function from part A has a discrete domain. Yeah.
I finished all the questions. Can I see it?
Why don't we just hold off to make sure they're all correct?
Yeah, okay.
Oh, you did? You got them all
then,
correct?
then I got double check them.
Sure. Then you can help me with all. You're doing great.
I got 100.
Good job.
Okay, now I have the answer.
I love the encouragement. It actually helps me. I'm like, okay, good. All right, let's go to number 3. Describe the domain and range of the function using inequality or set builder notation. I don't see a, okay, it's all the way over here. Okay. So describe it using set builder notation. Let me just see how the answer choice is written. Okay, first we're going to describe the domain. It says multiple, and if multiple answers are correct, select the choice, correct choice below, if necessary, fill in the box. Okay, so let's look at our domain here. What is our domain for this continuous, never-ending line? What is the domain? What is
Nothing.
the set of numbers for all of our x values according to this linear function?
I see one. Wait.
So you're saying there's nothing? Okay, what if I choose, I don't know, a point right here? That would be 0, 1.5. What if I choose this point? This would be 4, 5. Oops. Are there x values possible for this function? Absolutely. Do you want me to keep pointing out points and try to name all of them?
So it's just going to be real numbers.
Real numbers. So our domain is real numbers.
So basically, whenever it has,
So,
whenever it's continuous.
so it would simply be x is a real number. Good job. Describe the range of the function. What do you think?
I was cleaning my phone.
What do you think the range is going to be? What's the range, guys? All real numbers. Because it's going all the way up and all the way down and everything in between, right?
Yeah.
So the range would also be y is a real number. Okay, now we're saying describe the range. Wait. Oh, okay, I did that. We're done.
Oh, we're done.
We're done with that question.
Wait, but there's, oh, okay.
There were only 2 parts for that, right?
Yeah. I
Okay.
think so.
It's hard to tell because this is like the teacher one, so it doesn't like automatically bring me to the next question. It asks if I want to try again or go on. Okay, so analyze the following situation. Here's where things get a little crazy because we're talking about real life stuff. Analyze the following situation. Identify a reasonable domain and range. Is the domain continuous or discrete? So lots of questions here. A car has a 15-gallon gas tank and gets a maximum average mileage of 24 miles per gallon. So let's take a look at what that graph would look like. It says identify a reasonable domain for the gallons of gas in the car's tank. So it's automatically telling us what will be our domain, right? Our domain is going to be what?
That was disgusting.
15.
Our domain is going to be gallons of gas. Because it can hold up to 15 gallons. So we have 0 gallons, 1, 2, I'll just do this, like 5, 10, 15, that'll be easier. Okay, gallons of gas. So it says, how do we identify our domain then? If the car has a capacity of 15 gallons of gas, that's its capacity, that's what it's allowed to have. Is there a limit there?
Yes.
Yeah, what's the limit?
15.
15. What else is the limit? Can I have a negative negative gallon of gas? No. Can I have 0 gallons?
Yeah.
Sure. So how would we write that?
It's gonna be X is greater than 15.
It's
So-
Less than 15.
So would it be X is an integer? No, because we could have 2.5 gallons of gas, right? So it would be X is in between 0 and 15. You guys are doing so well.
When did it go up?
Yeah.
Wait, what?
Identify a reasonable range for the average remaining miles the car can travel without refilling its gas tank before it runs out of gas. If multiple answers are possible, use the narrowest possible answer. Select the correct choice below, and if necessary, fill in the answer boxes. Okay. Identify a reasonable range for the average remaining miles the car can travel. What do we need to figure out?
How many miles it can go?
On 15 gallons, right?
360.
360 is correct. Do you guys understand that? That in order to find those constraints, those limits, we have to see, well, how many miles can it actually go? So the miles can go all the way up. If it has 15 gallons of gas and it can go 24 miles for each of those gallons, we have to do 24 times 15 equals 360. So that's going to be our max, right? What's our minimum number of miles?
360.
Any number.
What's our minimum number of miles that a car can drive?
0.
0. Very good. So it has to be between 0 and 360. That's a tricky one. Emily, you got that right. It's really
Yeah.
good.
No,
Go
well,
back to
so
it.
I was having troubles on like the second part, and yeah.
It's okay.
It was,
It's okay if you like had to do it a couple of times.
yeah. But I have an
That was it for this one, right?
No.
No.
Is there more? Oh, I'm sorry. The domain is, would the domain be continuous? Meaning, can we have, like, 2.5 gallons of gas in a car?
Yeah.
Or are we only allowed to fill up, like, 1 gallon of gas and then we have to go straight to 2 gallons of gas.
No.
No, when you're at the gas station, it fills up like the parts of a gallon too.
It's gonna be continuous because it just like, it doesn't like hop around.
Yeah, it doesn't hop from gallon to gallon, it pulls it in. Since it includes all real numbers over each interval. So the interval from 1 gallon to 2 gallons includes all of the numbers in between 1 and 2.
And I had troubles on this part.
Okay.
Do all these questions
All right, so the table shows the number of minutes through. So, okay, this one was really tricky, okay?
This one
This one I needed help on.
Oh.
The number of minutes Drew spends in each class for each of 2 weeks. Assume that the biology lab, which is down right here, okay, I'm gonna erase that stuff. Assume that the biology lab is the one class Drew may or may not have on certain weeks. So that means he could have a biology lab of 0 on this week or 0 on this week. 0 minutes, because it might change. This week could have 0, or his second week could have 0. The tricky part of this question is you have to really read the parts here, because it's really saying, it also says that the duration of each class will be only one of the times shown in the table for any given week, which also means, notice how this is 60, 60, so that doesn't change. This is 90, 60, everything at 45, 45, 45, 45. So this and this are the only ones that could change depending on the week. So here's what we need to do. Describe the domain and range relating the number of classes to the total weekly class time. So the domain would be how many classes he could possibly be taking. How many classes could he possibly take on week 1?
5.
On week 1, how many classes would he?
4.
4, because biology lab doesn't exist on this week 1. What about week 2, how many classes? 5. So those are both possibilities for a domain. He could either be taking 4 classes or 5 classes. So we would simply write that x equals 4, comma, 5. Well done. What is the range? Now here is where I got it wrong, you guys, and I had to call sweet Mrs. Selset and ask her, and she said, I had to read this question like 5 times. I said, thank you, I thought I was something wrong with me. Yeah, so the range, I only put 2 numbers. I added up these, and I added up these, and then I put those 2 numbers. Those were only half of the numbers that we needed. And then I realized, oh, okay, since these are just examples of what a week could look like, and that's an example of what a week could look like, technically, on another week, week 3, he could have a 60-minute English class, because that would be the same. He could have a 90-minute, a 45-minute, a 45-minute, but he could also have a 60-minute biology class if he had that class on this week. So that would have to add up to what? Somebody do that on a calculator. And then week 4, he could also have, he could have a 60-minute class, and then instead of a 90-minute class, he could have 60, and then 45, and then 45, and then he could also have 0 for biology. So you have to add up all of these,
270 and 210.
all of these,
210.
all of these, and all of these, and you're going to get 4 separate values for your range. And I believe it's 210. Can somebody add those
Yeah,
up real
210
quick?
and then 270.
Yeah, but I need, 210, 270 for,
Well, for week 1
I need
is
week 1 and week
210.
2 also.
Week 1 is 210 and week 2 is 270.
1 is 210, and then there's 270. What are week 3 and 4? Somebody do it on a calculator real quick, because I have one more question to do. Is anybody doing it on a calculator?
Well, I don't know.
I have the numbers.
Week 1, where is it? 210.
All right, I'm skipping it because you guys know that you have to add those up to get to the next answer. I'm just going to number 6 really quick. Because I only have 2 minutes, don't pack up.
We have 1 minute.
Oh, you have lunch next, right?
Yeah.
Yay! Okay, then just for a second, I have to record the video for everybody, okay?
Be quiet.
This question right here is a test question. It looks just like one of the test questions that you will have at the end of this topic. That's why I included it. A local store sells yogurt drinks for $1.50. The function that relates the number of drinks purchased to the total cost is shown. Pilar can spend up to $10 on drinks. Select all the statements about the domain and range of the function that are true. So they gave us some constraints here. Let me pop this out. Okay, so it says select all that apply. It's talking about the domain and the range. So we need to find the domain and range of this situation. What is our domain here? We've got 1, 2, 3, 4, 5, and 6, right? Those are all potential x values, right? Is it continuous or discrete? You can go, Zach, if you want. You guys are staying with me. It's extra help. Sorry, Abby, it's only $1.
Well, what about me? What about me?
And I'm sorry for you too. Okay? Listen, you were wasting time. We're wasting your time. Okay.
There's another part to it.
Yeah, I know. We'll get through all of it. It's just a little bit. Our domain, our x values could be 1, 2, 3, 4, 5, and 6, according to the graph. Is it only those values, or should I use 1 and 6 as the endpoints and x is between them?
Yeah.
Yes.
So you're saying that x can be anything between 1 and 6? X can be 1.5?
No.
Nope, that line is discrete. It does not continue. So x can only be 1, 2, 3, 4, 5, or 6. So it says x is an integer and it has to be between or equal to 1 and 6. Now let's look at the range. The range here is 1.5, 3, 4.5, 6, 7.5, and 9. So how do we do that? The range is y is a multiple of 1.5 and it goes all the way to 9. Does that sound right? Okay, here we go. Do not pack up. What if I get one of these wrong and then you guys packed up and I did it wrong?
I did.
Is that it?
Yes.
That's all, question 6? Okay, bye-bye, have a great lunch. Sorry that I taught you extra. That was sarcasm.
It's okay.
It's okay.
You don't feel bad.
Is that chalk? Oh, it looks like chalk.